Okay, in this example problem, we're going to find the B field at a point in space, but we're going to use a little bit of symmetry, and it's not going to be quite lined up right. So let's kind of see how that all works. Two wires are separated by 8 centimeters. The wire on the left carries 2 amps. The wire on the right carries 3 amps. Each wire is 5 centimeters long. Find the B field in the dotted box below. The dotted box is 4 centimeters over from both wires and 4 centimeters up from both wires. So that's nice because that's going to make a 45-degree angle if I connect the center of the wire to the center of the box. So there's my line, and it's 45 degrees because it's 4 centimeters over, 4 centimeters up, 4 centimeters over because the total distance is 8 between them. So I'm looking at half that distance. Great. So that gives me a little bit of symmetry to work with, and that's wonderful. Now, I've got to find the direction of the B field in the box. I'm going to start with the left wire. I'm looking at the B field at a distance from a wire, so that's Ampere's law. I'll use the closed right-hand rule, so the current's going into the page. That's what the X means. And that's going to show me it's going to rotate in a clockwise direction. So I'll look at the circle, tangent to the circle at that point. It's just going to be 45 degrees because of where it's located. And then I'll do the same thing for the other wire, also clockwise. And tangent the circle in the box means it's going to point 45 degrees going upwards. There we go. There are two B fields. B field to the left wire, B field from the right wire. Now give me a little frame of reference to the horizontal line, and I can see it's also going to be 45 degrees because alternate interior angles to the 45 to the parallel lines. Or similar triangles, actually, is the way this one's going to work, sorry. Alright, let's move on. Let's separate these two out just to get a little clarity so I can see things. Now I'm going to find the components of the B field on the left wire. So it's going to go over and down. Components of the B field on the right wire, that's going to go over to the right and up. And I can see a little symmetry here. The B field on the right that goes up and the B field on the left that goes down, those two components, they're the same length. They're going to cancel each other out. So I'm not going to need to calculate them at all. So these two are going to go away. Great. Now I've got the horizontal ones to work with. So I'm going to have the B field do the right wire in the X direction, the B field do the left wire in the X direction. Since they both point in the same direction, that tells me what to do mathematically. Mathematically, I'm just going to add them up. I don't need to subtract anything. If they went opposite directions, I would declare one of them to be positive and then have a positive and a negative and subtract them. But here, they both point the same direction, so I'll add them up. And my final answer, I know, will also go to the right because it's my only choice when I'm adding them up. So let's find the B field to the right wire. Since it's a point in space, and Ampere's law is what we're going to use, mu naught I divided by 2 pi r using the wire on the right. And I'm looking for the X component. That's where the cosine 45 comes from. I'm looking for the distance now, so I can know what to put in for r, and I'll use Pythagorean's theorem. And I get 4 times the square root of 2 centimeters. So that's the distance. Then I'll finish my calculations, and I get 0.00015 teslas. So that's what the B field on the right in the X direction. For the left, I go through kind of the same set of calculations, mu naught I divided by 2 pi r. I want the horizontal component, so that's going to be cosine 45 of mu naught I times 2 pi r. And then it gives me, when I put in my numbers, I'm going to get 0.0001 teslas. That's the B field on the left. Because the B fields point in the same direction, I'm going to add them to find my total answer. So the B field on the left plus the B field on the right, when I get my total, I get 0.000025 teslas. And since they point to the right, my final answer will also point to the right.